So thank you for coming. We're together for about 25 minutes, and I will talk to you about gRPC, REST, and GraphQL, all about APIs. I'm Cedrick Lunven. I'm leading the developer advocacy team at DataStax. So DataStax is the company that provides Cassandra in the cloud as a service, so not so much API. But still, we have some things to show you. So if I ask you to build an API, you have plenty of choices, but some, I think we could consider that they are deprecated, SubCorva, RPC, RMI. I did all of those. I enjoy, or not so enjoy. But for today, just those three. And in 25 minutes, of course, it will not be a deep dive of each one. It will be a feedback of our personal experience at DevRel. So DevRel, our goal is really to make as many people as possible using the Cassandra database. So we pick one or the other. We fundamentally not have any preference, but we have implemented a lot of components using each of these, and even the same component using multiple APIs. So that kind of a personal feedback. So this is the architecture we tend to show at every live workshop we are doing weekly. And so we each time put Cassandra as a database, no surprise. And then we switch in multiple technologies, front-end, back-end, JavaScript, Python, Go. So I have a lot of fun implementing all these components. And of course, we also change APIs one to each other. So REST, I'm pretty sure everyone in the room is already kind of an expert of REST coming to these API days. So I will not make you the offense to explain you what is REST. One resources that I keep using. So first, maybe one thing, you can take a picture of this slide because here at the top, there is a GitHub organization where we share for free all the components that we built. And so when we do Java, we are using those three frameworks. So there you will find some component using REST, gRPC, and GraphQL with Spring GraphQL, Quarkus, Micronaut, Express, Apollo SQL Server, Netlify, FastAPI, Flask, and Django. So yeah, that's just the framework we tend to manipulate. But yeah, here the important thing is really at the top right-hand corner, just the GitHub organization. So that's REST. Let's move quickly. I only have 25 minutes. So the resource I keep using is this RESTful API design from Octo. 10 years old already, but it has not changed so much. So REST, resource base, leveraging WWW philosophy, using REST resources, reusing the HTTP verb, and all the rules that you already know. So I'm moving quickly. You are using noun, plurals, but here, even in the ref card already you see, immediately when you talk about REST, you think about create, read, update, delete, which is a bit different because with SOAP, we used to think about function and things to execute. Here it's more create, read, as update, delete, and that will resonate with our comparison matrix. REST, with the databases, you might think, why not generating the REST API for you? You have your database, let's generate the API. And you're not the first one to think about it. We have a couple of framework and technology that move over the year, but not really a huge adoption. We used to have OData V2, V4, not so many. Now you see some scaffolding tool. Hey, give me your data model. I will generate for you that repository layer and that REST API layer. So here I put just Spring Data REST. And Jeepster is an app generator. You just provide your entities and it will generate you some REST resources using the best practice and principle. So there are so many rules, so now you can almost do this scaffolding and generate some standard REST API. At the same time, the adoption is not massive. Okay, so read this one. An overview, do not expect anything that you will learn. So now GraphQL. How many of you already are using GraphQL in the room? Okay, not so many. So that's the promise, right? It seems super sexy. GitHub is using that. Netflix is using that at the GraphQL Federation. So it has been created by Facebook 2.12, released open source 2.16, working on HTTP, still using kind of JSON-ish. And the philosophy is the following. You will design some entities. So here, type and shows. Okay, strongly type it. Based on HTTP, still JSON. Okay, so far so good. And in your request, in your queries, you will exactly express what you want. So now when you build your query, of course you invoke a function, the type of entities you want to retrieve, but in the values you retrieve, you actually say, hey, I want only this, 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 and this. The idea is to reduce the payload and only get only what you need. Also, you don't really know what's there, and see that there are nested items. And with GraphQL, you can actually get some data from a single database, single source, but you can also get those data coming from multiple sources, doing some composition, some federation. It's called GraphQL federation. It's also called schema stitching, because here you are working with a single schema, and under the hood, it will gather data coming from multiple sources. So it can be multiple queries side by side in a single invocation, but also you can create links from data coming from multiple sources. This is where the real federation is coming. So one thing nice with GraphQL, I give you the endpoint. By the way, it's a single endpoint. When you expose a GraphQL, it's a single endpoint. You can invoke that endpoint, and the endpoint will give you the schema. All the function, all the method available. It's like the good old WSDL for WASDL for those in the room. So it's auto-discoverable. So pretty cool. You don't need that OpenAPI or Swagger that you see for REST in the previous slide, where you don't know what are the resources and exactly what the payload would look like. So here, you do have the schema also that will reflect it in the tool you will use to test your GraphQL application, like GraphQL or GraphQL Playground, because you could have the auto-completion, of course. So I told you when you build a query, you get exactly what you need. Okay, so I will move that quickly. Two types of queries. So a query is read-only, like a select, and the mutation is the other one, and it's, of course, like insert, edit. Okay, so update, delete. Anything that will update the state or your data will be a mutation. Okay, overview of GraphQL. Grpc. Grpc has been created by Google. So Grpc actually means Google Remote Procedure Call. And the idea is, again, to use HTTP. But this time, the payload will be serialized binary format. The idea is not only to reduce the payload size, but also to speed up. Here, the idea is all about speed. Google using Grpc for the services-to-services communications. How does it work? Well, you want to build a Grpc API. So first, you start with your interface. Your interface will be exposed with a file called proto. The underlying serializes format is called protobuf. They could have picked Avro, they could have used something else, but hey, as a coincidence, protocol buffer also has been invented at Google, so maybe that's the reason. But it's pretty, pretty effective. Not auto-discoverable as Avro could be. But so here, if you want to consume a GraphQL endpoint, this time you need that interface. You need those proto files. And with those proto files, you will generate your client. You will generate a stub. Back to RMI. So you generate the stub, but the stub can be generated in three forms: synchronous, asynchronous, and reactive. And that makes sense because it's all about performance. So having this async and reactive is quite helpful to build some non-blocking apps. what a proto look like? So it's look like that. You define a couple of functions, and then you will define the parameters. So here I put what a query look like here, and here you can nested some struct. It's really make me think about the C struct. But the level with the finest granularity is as basic as this one. So here you got a decimal, or your first level of object. Here you really have the primitive int 32 byte int, and in the binary format it's all encoded with some offsets. So here if you want to read the values, go to offset XYZ and go to this offset to access this ID. So the issue with that is any version is a major version because it will break immediately compatibility. So if you work with Grpc, super fast, super performant, but you need to version the proto, the interface. And also you need to have those files available, kind of the web server, and use it as an input where the developer, join in the morning, build the app, it will get the latest proto, start building with that, and see if there is a compilation issue. Which is good with protobuf is those clients can be generated with so many languages. So if your client have some fancy languages like Rust, Erlang, whatever, you can easily generate a stub. So at DataStax, having some API, we say, hey, for that API to be used by everybody without having to recreate or re-implement the drivers, because DataStax created the Cassandra drivers. The idea is to put a Grpc API on top of Cassandra, because now we don't have to care about the drivers. We expose the Grpc, and that's for the client to handle that. Especially because Grpc can do load balancing, failover just by the protocol. Okay, that Grpc, you got an overview of the three. We are probably already 10 minutes in. So now, when should you use which? But you might understand that I had to give you an overview of the three first. So, as a good French architect, I say, let's build a decision tree. And to build that decision tree, we need some criteria, and the criteria should not only be technical. Of course, you start with technical. Can I do kernelity, versioning, confidentiality, atomicity? If I don't do some search mapping, especially for data-oriented API, filter paging, and integrity. And then you start to realize, hey, it's not only me. What about the people who need to interact with my API? What are my clients? Open, external, internal? What kind of client? Do I need the documentation? Yada, yada, yada. So you do your matrix, and sorry, it's in French, and you say, oh, I will put some weights and say, oh, based on each. Actually, it's a real matrix that I it's personal opinion. But my conclusion reading this matrix analytic and building that is, okay, I have so many rows. How do I prioritize which rows should come first in my decision tree? And so, you come with that and say, whoa. Okay, I need a website for my decision tree. So, it is not what I will share with you when you take a picture today. On the other side, what I want to show you is, hey, I have this same slide for the three technology, and that's my personal experience based on exposing and using the three. So first, GraphQL, the discoverability introspection is very important to me. I go to a new provider. Do they have a GraphQL? Because I get the schema. I put my GraphQL playground, and I can start shaping my query with auto-completion. That's super important. Especially because I will come back to you. Declaring data fetching, so that's composition and federation. Schema teaching is federation. Data fetching is exactly when you expose a GraphQL endpoint, you can express exactly how the data will be fetched. And that's good because it will compensate one of the drawbacks, which is complex implementation and nice for customer. Customer, single endpoint, get a query, get 30 level of nested object, But under the hood, for the GraphQL API to get you all the data, there is 100 requests happening under the hood, and you can kind of flood your database just because the user can think it can do any kind of join or how many nested livable. When you go nested, you should think that actually it's a join, and each time it's lost. So you read the slide with me. So to me, GraphQL, sweet spot is backend for frontend. Kind of backend you create specially for your specialized web app or mobile app, just to reduce as much as possible the payload. GraphQL Federation, as Netflix put, I'm not very confident. How would you force people to use exactly the schema that you have decided on your GraphQL? So global GraphQL, I don't think, especially because it's a single endpoint. How would you versioning? It's not really possible. You have to need two GraphQL side by side. What about those API management solutions that you see here in the hall? Maybe you want some dedicated policy for each resources, for each, depending on what you do. Here you have a single endpoint. So the policy you applied at top level will probably be applied everywhere. So it's not the same level of granularity. Catching is not easy because the diversity of the query from your user is also have a lot of variety. REST, I will move quickly. I also see the time. Decoupling flexibility. REST is, to me, and keep and stay, CRUD superstar. And this is still the one you may want to use or do scaffolding. And you see that all the scaffolding framework keep pushing for REST. It's a simpler. It's still cool. It's still cool. I mean, it would be use REST as long as you can, right? It's like use relational database as long as you can. But sometimes you cannot cope with the scalability, throughput, and then you have to think about something else. Grpc, last, all about performance, serialization format, so HTTP2, multiple stub. Now it's strongly coupled. Each version is a major version. No discoverability, you need those proto files. So here it's used as Google for the distributed network of service, high throughput. Also it's command like RPC, as the name stated. RPC is more to execute a function, execute a treatment. On the contrary of West, which is just interacting with low-level data. And with the time I leave, because as of now I have nothing to sell. What if you did not have to choose in between the three? What if you have your database and you put so I will move quickly with what is Cassandra. Okay. Cassandra is cool, trust me. High availability, linear scalability, low latency, global distribution, scale as much as you need. So what if on top of this database, you want to get those API? Because interacting with the database, you need to know SQL, you need to do SQL, you need to know Cypher if you're working with Neo. Each time you have a new language to learn, what if you could put that proxy on top of it and get the APIs for you? So here, second open source project called Stargate, working on top of Cassandra, okay? And then you expose REST, gRPC, and GraphQL. And guess what? This is also a reason why I interacting with all those, because on daily basis, I need to do the demo with the three. But before that, trust me, I also build some backends with those three as well. And this is what you see in the GitHub organization. Okay, so that's Stargate with all those nice APIs. So before you had Cassandra with a lot of nodes, data nodes. Now you can put Cassandra in front of it. Now you are stateless. Now you can make the compute layer scale independently of the data layer. And you have a nice load balancer. So this seems to be, that's just something. But to be honest, it is required for us to move to the cloud, because here your client drivers need to enable a connection to every single node. So if you move to the cloud, you still need to maintain those connections. Hey, it's not working. What if here it's a Lambda function, or it's a native compile Java binary with GraalVM? You want to start super fast, you want to execute super fast. If at launch you need to initialize your connection to the database, it could take 1 second. And if your Lambda takes 1 second to start, you're screwed. So you want really to get this stateless layer on top of it. And our goal at DataStax is really for as many people to use Cassandra. So easy to use, easy to deploy. So we have done all the works needed to have the Cassandra operator for Cube, the Helm chart to deploy a Cassandra cluster, and also Stargate. And not only that, actually in the Cassandra project, as we call that, you also have backup monitoring, backup and monitoring and security. But it's not competing with API management. It's just exposing API on top of of your database. Then you can still use all the nice API management solution. Throttling, monitoring, security could still be under somewhere else. Service mesh as well could also be under server. It's just a proxy on top of the database. That's the Cassandra project with everything. Again, so far, everything that I've shown to you is free. Free the code, free Stargate OSS, free Cassandra OSS. My last slide would be all those innovations has been put in the Stargate project. So here, when you should use which API. So this one is kind of the DataStax website. Based on everything that I told to you, hey, this is everything we do. And the last one, maybe in 1 minute. And now we do have a proxy on top of Cassandra. So the first 3 API is, okay, translation of protocol. You used to interact with the database using SQL. Now you can use the API, but it's still SQL-ish on the interface. But because we have a proxy, we can add extra value. And not monitoring, not throttling. But here we have an API that allows you to interact with Cassandra as a document-oriented database, as it was a document-oriented database. So here you can deal with collections, document, search on any field, and use the underlying data layer as it was a document-oriented database. So this is also a kind of innovation we are building. And with this proxy, we are keep adding APIs there. So next will be a DynamoDB, compatible API. Again, always just a proxy. And under the hood, it's still Cassandra. So all those innovations, and that's my last slide, are actually in the DataStax Cloud Platform. I guess I had finally something to sell to you. So Cassandra as a service in the cloud, Astra. Astra is a platform with multiple services, database and streaming with Apache Pulsar, you know, the competitor of Kafka that everybody asks about. So with the proxy, Stargate, all these APIs are available. And for the Pulsar, same, we put another type of proxy, also open source, called Starlight. And you can do GMS on top of Pulsar. You can do Kafka compatible API, AMQP. It's all about the cloud. So when you start a service, you can pick the interface you like and deploy where you like. And if you don't like one cloud, you can switch. And if you were already using a cloud provider, search for Astra in the marketplace. We are there, and everything you create there can be linked to your VPC. And with that, I think I'm just finished. Thank you. Oh,